think you can see it. Okay. Are you all doing well? Are you ready for the last 20 minutes? So I see like some yes, some thumb ups. Okay. So you know me, you don't need another introduction. So when you log in on Shaheen, so you have 3 different compiler available. So you have the Cray by default, you have the Intel, and the GNU supported. So on Shaheen, it may be like, you will see like, so when you log to Shaheen, so you have this welcome message, and then you have the many modules that are already loaded. So you don't do like a module purge, you let it as it is. And because you have kind of what we call a programming environment that will help you to make things very easy to compile. For example, if you don't like to use the Cray compiler, you can switch by doing module swap programming on Intel or GNU. And to compile a Fortran code, you don't use the GNU Fortran, you don't do ifort or MPI ifort or MPI CC. You use only these 3 commands: ftn for Fortran code, cc in lowercase for C code, and capital CC for the C++ code. Okay. And this is an example. Like here, if you are on Cray, you do ftn -03 for the optimization, my code. If it is in C, the same thing. If you would like to change it to Intel compiler, you do module swap, programming environment Cray to programming Intel. And then the same code, I compile it as it is, okay? The same thing for GNU. Oh, I don't like GNU, or I have some issue with Intel. Then I swap from module swap, program PRG env to Intel to GNU. And exactly the same code. So basically, for the people who are coding, your make file will be clean. You will not have like several lines where you have if it is for this machine or if it is for this compiler, okay? So you don't use the MPI CC or MPI Fortran. And you see this command is the same for serial code or parallel code, okay? If you would like to know about more the option about the flag, you just type the main and for the ifort or ICC. So I repeat, so we have 3 compiler, you choose which one you would like to use. In general, like Intel will give you like a good and decent performance optimization. Cray compiler has like many features, especially with Fortran. This is the one that you should use. For GNU, it's mainly for portability, especially like for old codes, or you took it like from someone else. This is like it will compile very easily. So by default on Shaheen, we have the dynamic linking. You don't need to do the initial stuff. If your code needs to be static, so you need to add this flag -static flag, or you set this programming environment, you do export Cray PE link _type equals static. Okay. For the people who are kind of advanced, they are using like automake or CMake. So make sure you compile like on the login node and run on the compute node, eventually the configuration. This is what is sometimes. And sometimes specify the --host equal x under x86_64 unknown Linux GNU. So this is kind of a tip. Okay. Also, for the people who are looking to use a Clang, CLang, Cray is by default for C, C++ using the Clang. Okay. For the people who are doing OpenMP, so you can use a flag, so -f OpenMP for C and C++ because it's following the C Clang. And for Fortran, you add -h OMP. With Intel, it's -q OpenMP, and with GNU, it's f OpenMP. Okay, so many of you, sometimes when you write programs, so you use like the Intel library or you are looking for BLAS and LAPACK. You don't need to download these packages or even MPI. So MPI is already by default available in the programming environment. So you just compile in your code. Same thing like, we have by default, if you look at the, someone has, is not muted, I believe. You can see like the Cray website is a collection of different scientific libraries. And so it has a BLAS, BLAT, LAPACK, and some FFTs. So you don't need to add any flags, you just compile and link. It will be by default, okay? For those people, like I have seen like in the question, like people about Python or R, we have it, and it's already optimized by the Cray, and we have also our own version that it includes some typical packages, and the version calls the OpenMP threaded version of Cray libsci. And so we, during your run in JavaScript, or what Sam has shared earlier with the job generator, set up correctly the OMP num threads. Okay. We have also several packages, like the FFTW is a optimized FFT on Cray hardware. We have also the PETSI library for the people who are doing a lot of numerical libraries. Trilanos also. So same thing, you can see in the list as like Ruh has shared, Xeong, the list of apps that we have, and you just need to load the module and compile. And you don't need to edit your make file and add many libraries and so on, okay? Same thing with Cray TPSL, like you have like for the people who are doing MUMPs or SuperLU for this type of. If you don't, for a reason, your code depends only on MKL, yes, you can do it. You just need to unload Cray libsci and follow these links. If you click on the Intel advisory link, and it will share with you the path variable to add to compile your code correctly. You have seen this package or the list, so you all are. Also, when we shared with you that you have a lot of package, so you just do module avail, and you have like over 150 packages. Yes, don't get scary. It's just like to show like how rich is the environment. So here, the top lines are mainly from Cray, and you see this is all the optimized like from the Cray that we have seen, the GNU, the Intel. We have also like some of the debugger will see it. Some of for the people who are working on climate or with the large data, they need this IO library like NetCDF, HDR5, and so on. Then in the second part, all this is all the packages, the third-party packages that are installed. It's mainly about VASP chemistry, like what Xeong has shared with you, and also like some CFD, like what you see like here, ANSYS, and so on. And so different packages. So before you install the package, check if it is available. Here, this is the must that you should have. And you can use your phone to get the QR code. This is like kind of the cheat sheet or the flyer that you can post it in front of your desk or next to your laptop. And so this is kind of summary of all what our colleague like have shared with you within brief information, like how to log in, how to compile, how to do like a job script, what are the type of the queues, how to store, like how it has been explained, how to check your account when you have an account, so you can check how many core hours you have left, and you can see and when it expires. Some of the flags here for the compiler, and some of the tips on how, well, what are the IO library, visualization tools, and so on. Okay, so just click on this link, or now with your phone, you can do it with the QR code. Okay, so we have for the people who are advanced, the CDT. So usually we have every like 3 months, we don't have the latest compiler, the latest library. We don't change usually by default. We'll make, we will tell you, however, for more performance, if you just do module load, like for example now CDT/20.06, it will upgrade you the latest compiler, the latest MPI, and so on. So you can gain like from 5 to 10% even in some cases. Okay, now we are going to go quickly about the performance. So most of you are looking for like access to a supercomputer to do things like more, to treat with more data, but also to get performance. But also you have to be careful with the performance. You need to make sure that your results are correct, because what's the point of computing fast and you don't get the correct result? And this is remind me like this, probably this joke that you have heard. Like there is a guy who wrote in his resume, "I'm very fast in calculus." And so the interviewer was like impressed and said, "Okay, why you put that very fast in calculus?" Say, "Yes." "Okay, I will change you." Okay. So he told him, what's the result of the operation? 1,254 by 2,672. And the guy said immediately, 512, khalas, this is my final answer. Oops, this is wrong answer. So the point is also with terms of performance, it's good to go fast, but you have to make sure that you have the correct result. So when we say like you get faster result, more accurate, but also to have a higher resolution for the people who are working in climate or in seismic. So for example, this is the map of, you cannot know because this is a map with a resolution of 250 kilometers. If I do refine it, it's 100 kilometers. You cannot guess. But if you do with a 28-kilometer resolution, you can know this is the Alps, and this is Italy, and this is basically Germany. So you know where you are. So it's very important, okay? And also we know that time costs money. So the faster you can do the result, you can publish more, you can get more funds and so on, especially for the people who are in industry, but also in the academia, so they can publish. Okay, and also you have the chance to have a great machine like Shaheen, and KAUST has, like as my colleague said, like not only is about performance, but also like the service what we can provide. And you have to use it efficiently and effectively. I give you the example. It's like you have been given a gift as a Ferrari, and you would like to drive from Jeddah to Riyadh. But if you stay driving at the first gear, you will stay long to drive. So you have to change the gear, and the same thing. So you have to check how you can tune the performance, how you can find the bottleneck in terms of computation and communication. So the goal here, you don't try to reinvent the wheel. There are some people who did the job for you. So you don't need like to reinvent the wheel. And so basically anything that you have, okay. You can, so you can use many, there are several methods and tools that can be used. So you have like some tools that have some statistics, some visualization, and automatic analysis. So instead of putting like a right statement everywhere. So you have here on Shaheen, and we have many HPC system. You have several tools. You have gprof, PAPI, VTune, Alinea, Vampy, Tau, and so on. But the problem is, which one I should use? I'm confused, Bilal. Oh, okay. This is Harban. Okay, there is someone who is not muted. Can you please mute? Thank you. And you have several tools here. And indeed, so here, this is a very important message that it doesn't matter how many resources you have. If you don't know how to use it, it will never be enough. So you see, like to go to the next, to see the wall, you have several like ladder where you can use only one and it's working. Okay. So here the team is here to help you on how to use this script. For example, for the Python code, like my colleague has shared with you, you just put it into your Slurm script and you just type, for example, this command, srun -n1, Python -m, cprofile, my script, or for the call graph. And then I have this. I know where I am spending much of the time of my code. Or I can use this with Python. I use the performance DTD. So this is ARM, and I can see over the time the memory usage, how much CPU is used, and what is application activity. So I can see like I'm using only 28% and only a few megabytes. So I can tune more. So, and this is, it tells me where I am spending most of the time. So here I have a tool where I can eventually detect how I can run my code and how it is efficiently. So this is, for example, for the C code. On Shaheen, this is how you do it. So you can have like a, so an ARM DDT tool performs like you just need to load the module load ARM. Then you type make profiler libraries. You compile again your code, and you do perf report srun -n2 your code. And then you get a visualization report in HTML or in text. And you can see like my code is mainly, okay, good. It's mainly compute bound, and only the communication is 6%. And here it tells me advice. Oh, this is like probably I need like to vectorize it. Or the IO, I don't have an IO, it's good. Here the memory usage is low, so I can improve it. Energy is quite good, and so on. Okay. I can check also about my IO, how it is, because it's very important. So you have like with Alinea or with Cray profiling or Darshan, it will give you some numbers. Don't worry here, I'm just giving you like some previews of the tools. Hopefully, like in the couple of next month, there will be a webinar of 1 hour dedicated to these tools. Okay, and the same thing like what my colleagues Ziyong, Sam, and Ruh and Saber will dedicate it in the future, like 1 hour session on these tools, on how to do it. So here it's like a movie. This is kind of trailer. So this is kind of preview. Debugging. So you have a code, how you can compile and how to check. So you have Valgrind, how I can find the memory bottlenecks. So I just need to type to load the module, to export this variable, and then to run the report. If my report is clean, I have no memory issues. Okay, so this is Valgrind for HPC. Same thing with the debugger. So you just load GDB for HPC, and like the GDB, it will kind of find like the bottlenecks or the issues if I have a segmentation fault or error. So for example, here I'm launching my application, I load, and then I launch the executable. And here it will tell me where I have the issues, and I can tell what is the value of this data. So you can use also some tools, like again, with ARM and DDT, you just compile with the -G, so to make sure that you have it. You allocate a node, you load the module, and then you do a DDT exit.mpi, and then you have this toolbox opening Windows, and you run it, and it will tell you, okay, where you are spending time and where is the issues. Same thing we have also with Totalview. You just load the module, and you call TV8. By the way, it's not a channel, it's not a TV, it's just the short acronym. And then you have a Windows that pop up, and you just click on run my my last session program test. What is it? And I have a Windows of here is my code, and then I click on the button go to run, and then I see where is like the issue in my code, and to tell you okay it's here, and then I can check the value. So this will avoid me to write okay to do like a lot of printf or like print in my screen and to do like stops. So these are tools that will help you in detecting. Also, many of you are like how I can transfer my my codes and my files. So my colleagues has shared like there is a SCP, but this is recommended for small files in order of kilobyte. When you go to beyond like megabyte and so on, we advise you to use Globus. It's free. It's already installed on Shaheen, and you can install it on your laptop. It takes like less than 1 minute. It's free. You just go to this website, Globus. You register, and you can put it on your Windows machine, on your Mac, on your Linux, on everywhere. The good thing, it has a web interface, and you just click on it from your laptop to your screen. So when you are on campus on Shaheen, you have to choose dm2.hpc.kaust.edu.sa. While you are outside of KAUST campus, you choose dm1. Okay, and when you connect to Globus, to the web page, you have this screen. So I choose dm2 when I am on KAUST, and dm1 when I'm external. And here we go. And I can check like this is my what I have in my account on Shaheen, and this is on my laptop. You can see, and then I can do the transfer, and you see like I got the report, and here I even transfer it to outside in the US, and you see like it was transferred quite fast. Okay, and here we'll end the presentation with like kind of some like tips. So when you go, you connect to Shaheen, check if you have like any issue. Choose a compiler. They're not the same. Just do some tests, and if you need help, you are please contact us. We have already many libraries. You check with them because it's already they have been optimized, and you can run it. And for example, if like you use this optimized library, you can have a speed up of 10x. For example, like instead of writing your own matrix multiplication, you use these MKL or Cray libraries. Okay, so they're already optimized. Don't reinvent the wheel. We have several tools for debugging, for the performance, and for libraries. As we reminded, like check the accuracy is very important. For the profiling and so on, we'll go over it in the next webinar with like you have to do it in step, like we do it with small and short runs. And of course, we are here. We are to help you. We visit the webpage like hpc.kaust.edu.sa training, and please read the manual that we have on the website, the tutorial, and also in the mailing list, the tip of the week. So every week you should have, you can see from the KAUST announcement the tip of the week, so how to debug or what is like the nice reminder. Okay. Again, like this is how you check your account. So you can have like several accounts and you can check which one is active. Prepare in advance your project proposal, especially when you see like it's going to expire. Be careful that your account is not shareable, is per user. So the system admin are tracking the, so for security reason, make sure that it's one account per user. Shaheen is a shared resources. As we shared like earlier, there are hundreds of users active and we have in total 1,000 users. So be kind, it's like when you be kind to your neighbor, okay? And as reminded by Ruh and Ziong and Sam and Mohsen, the login is just to connect because this is where everyone is connecting. So you don't run on the login node. So we have, mashallah, over like 192,000 cores, 197 cores. So this is what you can run. The login is just like I would say the hall. So feel free to come in the living room where you can submit for your job. Last but not least, don't be shy. If you have any issue, you have us. This is great. I see like a lot of questions on the chat. And send an email to help@hpc.kaust.edu.sa. So be careful. help@hpc.kaust.edu.sa. And for every problem, send a new email. Don't reply to an old email. And also a nice reminder, don't send an email, basic email saying, dear HPC team, I need help, please. Okay, please provide us the details so we can help you on which HPC system you are, what is the problem, and what happened, what is the issue. Okay, and last but not least, please don't forget to acknowledge KAUST Supercomputing Lab and HPC resources used for your paper. This will help us also to get, hopefully, inshallah soon, the next Shaheen 3. Jazakumullah khair. Thank you very much. So thank you, and I see like we started almost like 2 hour, 1 hour and 50 minutes. We started with 100 users, and now we have 101. So thank you for your patience. And now we are going. I leave the floor to Saber, who will lead the question and answer in live, and he will share with us the surprise video.